In this example, we're going to show how we can use a logarithm to recover a limit in conjunction with L'Hopital's rule. So we might have an indeterminate form that looks something like this. Finding the limit as x approaches 0 from the right of 1 plus x to the power of 1 divided by x. Now, if we try to send x to 0 here, we would just have 1 plus 0, or a 1, and then 1 divided by something that is approaching 0, that's going to be infinity. That's an indeterminate form. 1 to the infinity is not a real number. We don't know what that is. So the idea here is to apply a natural logarithm, take the limit, and then remove the logarithm with the base e exponential. So let's do this. Now we're approaching x from the right-hand side, so we're only dealing with positive x values, which is good because the natural log of x is continuous there for positive x values. So because it's continuous, we can move the limit past the continuous natural log function, and I can look at the limit as x approaches 0 from the right of the natural log of 1 plus x raised to the power of 1 over x. So now that I've applied a natural logarithm, we will see if we can recover a real limit from this. Using my rules of logarithms, this power of 1 divided by x can move out in front of the logarithm. So we have limit x is going to be sent to 0 from the right-hand side, 1 divided by x times natural log of 1 plus x. So we just have to rearrange this. We have to rewrite it to recognize it as a L'Hopital's rule form. We have a natural log of 1 plus x in the numerator and a x in the denominator. This is recognizable as the indeterminate form 0 over 0. So we can use L'Hopital's rule. And L'Hopital's rule states that I can differentiate the top as 1 over 1 plus x and differentiate the denominator as just a 1 which is just the function 1 divided by 1 plus x, and as x goes to 0 from the right-hand side, this function approaches 1 over 1, or 1. So we applied a natural logarithm, we were able to recover a limit, and now to undo the logarithm, we should apply a base e exponential. So if 1 plus x to the 1 over x inside of a natural log approaches the value of 1, which is what we just showed, as x approaches 0 from the right, then applying a base e exponential will leave the left-hand side as 1 plus x to the 1 divided by x, right? It will undo the natural log because they are inverses of each other. And applying a base e exponential on the right-hand side, e to the 1, that's just e. So by applying a natural logarithm, we were able to show that the natural logarithm of 1 plus x to the 1 over x approaches 1. So therefore, the function that we were interested in, 1 plus x to the 1 divided by x, must approach the value of e. So applying a natural logarithm, using L'Hopital's rule, and then undoing the natural logarithm, we can recover the limit.